Good morning. If anybody's starting to come in, that's fine. I'm going to go ahead and begin because I don't have but 40 minutes with the lesson. If anybody wants to pop into the screen, that's fine. I'll keep the chat up for a minute until it becomes a nuisance on the side. We're going to begin where we left off yesterday with Algebra 2. We were working on, not yesterday, but the day before. Sorry, I was out yesterday. But we have 5.1 complex numbers. We were about to finish that up, and we need to go ahead and wrap that up and begin 5.2. If you don't already have it, you're going to need to print this off. I don't know if you can see this, but it says 5.2. I think I printed off page 10 through 15 on that file. So you can print off page 10 through 15 and follow me on the YouTube when I upload that. Just download that. And one of the students was asking me, how do you turn this in? There's really no way to turn in your work that you've done to show that, you have accomplished, what we've or been following, what we've been doing. Just send it to me through the email that I have, or you can send it through Microsoft Teams, I guess, but I would prefer it to come through your email, because just take a picture of it, put your paper on this table, click, and then upload it to the email, and that'll be the fastest way for me to get it. All right, so we're going to get back into what we were doing yesterday, and look at the complex numbers. Now this part right here is not very complex at all. It's just the only thing that makes it complex is because it's got an imaginary number here. It's just, how do you basically go from I to the 17th power to an actual tangible complex number? All right, so if you look at this, the easiest way to look at this is to group it in groups of 4. And the reason that is I was sitting here working it out earlier today. If you go back and look at your chart that we worked on, I to the, I is equal to the square root of -1, and blah, 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 all the way down to I to the 4th power equals 1. Well, this is pretty interesting because you can use I to the 4th power in the place of 1 anytime you want. They're equivalent, okay? And so that's what we're trying to do. We're going to take these large numbers and put them in terms of I to the 4. So somewhere down here, we're going to have I to the 4, okay? And we're going to figure out where. And so if you'll look at, how everybody knows how to divide 17 by 4. So you just take 17 divided by 4, and it goes in 4 times. You have a remainder of 1. All right. So what's basically going to happen is these two things are going to be your powers. You're going to have I to the 4. So in other words, you're going to have 4 goes into 17 4 times. So what happens is you get this this exponential multiplication thing going here. So I to the 4th happens 4 times, and then we multiply that by another I to the 1 because there's a 1 remainder there, okay? All right, so I to the 17 power is equal to I to the 4 to the 4 times I to the 1. And what's the point of this? Well, remember, I just said I to the 4 is actually equal to 1, all right? And so when you simplify this out, 1 to the 4th power is just 1. And I to the 1 power is just I, and so that means your answer is I. So what is I to the 17th power? It's equal to I. And remember, last time we went through the chart, let me see if I can find it quickly. Yeah, this chart here, it loops. Everything loops over and over again. So you got I to the 1 power, I to the 2 power, I to the 3 power. And I'm admitting some people. There's Soyan. Hey. Soyan? Okay, I don't know if you could see me. I'm going to go back to the, I don't know how to do this, so if you're following me, then I don't want to mess something up here. Okay. All right. So, okay, so let me get back to what I was doing. I'm sorry. I don't know what I'm doing here. Give me just a second, guys. Technical difficulties. Okay. Screen. All right. So I'll go back and edit that part out. I should have said her name. Okay. So let's see. Guys, I don't know what I'm doing. It's pulled up some kind of thing that's, I'm going to pause the recording just a minute. Okay, I'm back to kind of normal. I'm not sure exactly how it's going to look, but we'll see when we go to upload. And anyway, so this loops over and over again. So we've got, so in other words, I to the 17th would be either I or -1 or -I or 1. Well, it turns out that it's actually equal to 1. So if you go through the loop. Okay, and so let's go back and look at, okay, let's see. All right, I had a couple other people hopping in. I'm not sure how to put you guys up on the screen. I'd love to see you, but, and actually it'd probably be best if you didn't show your video, but that's up to y'all. Okay, so we've got 2 to the 234th power. How do we do that? Well, that's a little bit different. Well, it's not that different. You just basically try to figure out how many times will 204 go into 234. Well, then you sit here and mark this out. So we've got 5, 34, 8 times 4 is 32. So I'm admitting a couple, there's a couple of other people coming in. Hey, I don't know how to see you or say, hello, but good morning and hello. I'll wave at you. So let's get back to what we were doing. Okay. Now here we go. We got I to the 58th power, and what is, okay, how would 58 equate out? And, you could work the numbers out and figure out the best way to figure that out. You just basically take 58 again and divide it by 4. Remember, I to the 4th power is 1. So what you're trying to do is try to find how many I to the 4ths go into that. Well, it's okay. So this is what's happening here. I to the 234th power would equal I to the 4th 58 times. I'm sorry, I was going a little too far there. Okay, and then if you'll notice we have an I to 3 remainder, so that means we have I to the 3. Well, you can go back to your chart and look at what I to the 3 was, and I to the 3 was, hello? Good morning. Yeah. I don't know if I can hear you. I don't know how to set this, how this is. It's good to see. Well, I wish I could see y'all at the school, but it's good to hear from y'all. Okay. Let's get back into what we were doing. Okay. So let's go back to, okay, so let's go back to this part right here. So we just said that I to the third power was equal to -I in the chart that we did, I think Monday. And we just said that I to the 4th power is equal to 1. And 1 to the 58th power is no different than just saying 1. So it doesn't matter how many times you multiply 1 by itself, it's still going to be 1. And you're going to multiply 1 right here by -I. So what is the answer to, all of this mess over here? I to the 234th power would be -I, okay? And so that's how that turns out to be. So we're just going to keep practicing that a couple of times until we get it right. We're just going to keep going I to the 4th, I to the 4th. All right, now we are, I think, 10 minutes into the video, so about 30 minutes left together before I end. And remember, I want to try and get through 5.1 and then go on to 5.2. I definitely want to get at least somewhat into 5.2. So if any of y'all have any questions about what's going on right now, I will stop everything I'm doing and answer. Okay, but it's hard to tell if y'all understand it or not. But I mean, it's pretty straightforward. If you follow me, if you go back and watch the video again, maybe at that part that I just covered, you'll grasp it. It takes a couple of times to understand it. So remember, we're trying to figure out I to the fourth is the key. Okay, so we want to see how many times 4. Let me focus this. How many times will 4 go into? Okay, and so what are we going to do? Well, we're going to take I to the 4th power, and you know that I to the 4th to the 20th, 4 times 20 would be 80, okay? And that's most of what's here. Well, what's left over? Well, there's 3 more left over. So what you look at it is, okay, we've got I to the 4th to the 20th power, which makes I to the 80, plus 3 more. You have to add the exponents here when you're multiplying. So I'm admitting a couple of people here. Hey, bud. Good morning. All right, and so if you're just following me, that's fine. You can go back if you missed anything. You can go back to the YouTube video. And if, by the way, if my audio is too loud, please turn me down. Don't let me shout too loud at you. Okay. All right. So we've got. Miss you guys, by the way. All right. So we've got I to the 4th to the 20th power. So what does this mean? That basically means we've got 1 to the 20th power. And then I to the 3rd. And I remember I to the 3rd, and that last thing we just did, I know this is kind of jumbled mess right here. We went back and found out that I to the 3rd on that chart was negative I, okay? And I know that some of this sounds like foreign language to some of you, because you've never heard this part of math before, but it's okay. This is, these are just imaginary numbers, and I mean, they do exist, you know, but that gets into a little more depth into, you know, further down. If you want to take mathematics into advanced calculus or something like that, you'll learn that imaginary numbers aren't truly imaginary. They actually exist. Okay, and so what we're doing is just practicing with these exponents. So this is going to be your biggest key here, like on the ACT. Like when you see, yeah, when you see I to the 50th power, that's going to be I to the 4th power. And then you got to think, okay, well, what does 4 have to do with 50? How many times will it go in there? Well, okay, so you can just divide 50 by 4 over to the left, and let's see what happens here. So we've got 4 goes into 10 2 times, and we have a remainder of 2. So this is the number of times I to the 4th will go into I to the 50. So we're going to put a 12 here, and then we have a remainder of 2, okay? So I to the 2 power is going to be off to the left. So that's what makes this so complicated, is that you're just breaking this down into I to the 4th.
Today, like.
All right. So what is I to the 4th? Remember, it's 1. So we're going to put 1 to the 12th, and then I to the 2nd power off to the side there, okay? So take this back, watch this again, and we'll go and go slowly over how I did this if you're not understanding that. Remember, it doesn't matter how many times you multiply 1 by itself. You can multiply it 12 times, you can multiply it 20 times by itself. It's still going to be 1. And then I squared, if you go back to your chart, which you've got that, you should already have that from Monday. I squared, we found out, was negative 1, okay? Okay, so let's go back to here and say I squared is negative 1. Now, to be honest, I don't know what page this is. You can see closely where I'm at. It's 5.1-196, I guess. I don't know what exact page right here. That's where I'm at right now, okay? All right, so let's take a second. Does anybody have any questions? Those of you who are here, Are you understanding some of this, or? Okay. If you're not, it's okay. Just email me, text, send me a message. And I'll get back with you. All right, so let's look at this. We've got 121. How is that going to affect I to the fourth power? Or how is I to the fourth power going to affect that? We just basically divide. So if you have a calculator, some of you won't have this kind of calculator at home, but you can take any calculator, your phone calculator. And we're just doing this. Now look, you're allowed on the ACT to use your calculator, so get used to using it, okay? It's about speed when you get to that ACT. It's not about how much you know, it's how fast you can do it, okay? Because they only give you 1 minute technically per problem, and you better just, be a master at the calculator before you walk in to get a 36. So that, I think that, anybody is capable of making it, but you're just going to have to take the time and try to learn your calculator, and it doesn't matter what kind you have as long as you know what you're doing. Okay, so we've got 121 divided by 4. You'll notice it goes in 30 times with some remainder here. Okay, so we're going to say, okay, if 4 to the 30th power, or out of the fourth power to the 30th power, equals 120, how much is left over? You've got 120 here. We've got 121 here. That means we have 1 I left over, okay? And what's the point of I to the fourth? I to the fourth power is 1, okay? So we're going to put 1 to the 30th power, and then I to the 1, okay? So remember, I to the 20th power is 1, I to the 12th power is 1, I to the 30th power is 1. And then what is I to the 1 power? I. And okay, what is I? Let's go back and review that from last week, or last Monday, okay? So we've got I equals the square root of -1. Remember, it is impossible in the real world to have a square root of a -1 answer. So this cannot be a real number. It has to be an imaginary number. And that's what I is. That's what the I stands for. It's for the part of math that you can't touch, all right? So I've got a couple of people coming in. Okay, all right, so now let's go back and you can all probably figure out what to do next, okay? So we've got 180. We're going to figure out how many I to the fourth go into 180. Take out your calculator, all right? And I want you to second mode clear. If you have this kind of calculator, always push second mode clear first. This is a TI-84. And, go to yard sales. Go anywhere you can to find this calculator, because a calculator like this, you can find them for like 15 bucks or 10 bucks somewhere if you just look hard enough. And it'll last you all the way through college, okay? They were, back when I was in college, we had TI-82s and TI-83s. These things are going to be around for a while. So go ahead and try to locate one. You don't have to have this exact model. A TI-82 would be perfect. So, and those are like $5, all right? So push second mode clear, all right? And then do 180 divided by 4. All right, we get an exact 45 here. So what does that mean? Okay. All right, so that means that I to the fourth power will go into I to the 180th power 45 times. All right. And what is I to the fourth power? It's 1. Okay. Remember, we said that's the whole, going back to that chart.
6-year-old.
All right, so I to the 45th power is 1, so that your answer, if somebody ever asks you what's I to the 180th power, you can say, no doubt, the answer is 1, okay? Okay, so let's get past this stuff here. I'm gonna pause the screen real quick and let you kind of catch up with me if you're behind. All right, and if I'm going too fast, please let me know, because I can stretch this out over a couple of days if I need to. We've got all the time in the world at this point. So,
aren't we like not? Are we going? We're like not going back to school, aren't we?
You know, that's a good question. From what I understand, I'm hearing that, the world is focusing on April 30th right now. Everything's been
It's
kind of,
not going to be cured by then.
well, we'll see, but,
Which is why I downloaded a soundboard.
yeah. Yeah, so I miss you guys for real. I really do. I'm not just saying that. I miss the time we get to spend together in the classroom.
Break is getting boring, but if it ends, I have to go to AP World, and I don't want to.
Well, look, hey, let's for YouTube's sake, let's make sure we don't mention each other's names. I'll try not to say any names, but I know who you are, and you know who you are. So, but anyway, I miss you guys for real. I'm not just saying that. I really do, and I wish we could be back in the class learning. It didn't matter how early we got up in the morning. I still enjoy it, So anyway, we're going to get back to the next page, which is 179. We'll stop and chat here closer to the end. We're at 22 minutes in, and we'll go till 40 minutes, and then pause it and shut it off. But remember, if you ever need to talk to me outside, just make sure that you message me, email me. I'm always available. I'm always checking my emails, especially for students and parents.
I'm literally wrapped up in 3 layers of clothing, and I'm still cold.
Yeah, it's freezing today. All right, I'm in my little sunroom in here. I don't know if I'll show you. I'm in my little sunroom, and it's kind of a lot of windows and stuff, so it's really, really freezing in here. But all right, so now this is where it gets really interesting, because we're actually trying to teach you about quadratic functions. That's what the title of this lesson is. It's quadratic functions. And why in the world does complex numbers have anything to do with complex functions? Well, if you go back over here, remember we talked about yesterday that not yesterday. I keep saying yesterday. Monday. That a plus bi is the kind of standard form for a complex number. Remember, I'm going to say it again. A is the real part, okay? And bi is the imaginary part. And so it's just like every human has, part of them that's real, and then every human has their own imagination. So it's kind of like what makes up the entire human. It's their personality, the real part of their their imaginary part. So in a mathematical model, numbers are the same way. They're complex. Actually, if you want to get technical, all numbers are complex. All numbers have an imaginary part. Even the number 1, the number 2, the number 3, those all have an imaginary part. They're just hidden. Okay, they have a 0i added to them. See that? They have no imagination, no imaginary part. So technically, you could say they're all imaginary, okay, or all complex. I'm sorry. So, but that's too much for your brain to handle. Let's slide that up so y'all don't see that. Okay. All right. So now let's get back into what we were talking about, quadratics. And remember, we need to talk about FOIL method. Now, look, you may not see a lot of this on the ACT. What you are going to see a lot of is this right here, FOIL method. Okay. And so what you're going to get is you're going to have to multiply the first terms by each other. So what's the first term here? It's 2. What's the first term here? It's 4. So you're going to multiply 2 times 4. So my first term is going to be 2 times 4. Okay. Now, what's the O stand for? O stands for outer. Okay. So you're going to take your outer terms here, which is 2. Here comes my dog. He knows his way in. Okay, so I'll show you my dog. Come here, Charlie.
Bruh.
Come here.
Bruh. Bruh.
Let's see if I can show you my dog. He wants to come visit.
Bruh.
All right, here he is. Look, guys. This is my dog, Charlie.
All right, mate. Can you just unblock
He's the one
please?
that barks every time you hear birds come by. All right. Nope, don't bark right now. All right, so let's go back to outer. Let's teach him some math too. Charlie. Okay, so 2 times negative 5i is the outer terms, okay? All right, so this is what you would multiply here to get the outer terms. Now, what's the inner terms? Okay, hold on.
iDubbbz is a simp now, George.
That's what you get in the real world. You get animals.
What did you say, Max?
Okay.
iDubbbz is a simp now, George. How dare you?
Okay, so the inner term of
Wait, wrong
is trying to spell the word
Wrong button.
first, outer, inner, last.
What is
And you're going to get the inner terms now, which is 3i.
I'm gonna have to report you back to good.
Times 4. So what is that?
I have to report you back to Kunstkamp.
Okay, so in the last terms are going to be, everybody get this, 3i times negative. Now remember,
Bruh.
minus signs are sticky, okay? They stick with that number, okay? So if you
Max,
see a
why do you
minus
have
sign in front of a number, you might as well go ahead and consider that a negative, okay?
Why does Max have a 1080p webcam, guys?
All right? So now let's check this out. So F is 2 times 4, which is 8. O is 2 times negative 5i, which is negative 10i. And then I is 3i times 4, which is 12i. And then the last term is 3i times negative 5i, which is negative 15i squared. Now this is important right here, okay? Remember, I to the first power was 1, but I to the second power is negative 1. Okay, go back to your chart and let's look at that. All right, let's pause. Now look, they'll hit me if I upload this to YouTube and I get music on here. They're gonna hit me with a copyright, and they'll take the video down. So you gotta watch that.
I don't really think they're gonna be like, tidy YouTuber copyright.
Okay? They will. The copyright people.
Plus,
will
I
take you
don't.
down
I don't really think anyone.
That's
I
why
don't really think anyone cares about this getting copyrighted.
So let's look at this real quick. So if
It's
you go back and
everywhere.
look at your chart that we finished on Monday, I squared is equal to negative I. And so if we go back to the page that we're here on page 5.1-197, and we're doing the FOIL method on this. These are called binomials. In each binomial is actually the standard form of a complex number. So you've got a complex number here and a complex number here, and you multiply them together, and you get this, okay? So let's look and see what we can combine, okay? So we can combine the i's, and we can also deal with this I squared, which we just found out was negative 1. So you can go down here automatically and put negative 15 times negative 1 easily, okay? That's going to be a real number. It's going to be a real number. This is going to be the imaginary part. We're going to put these two together here in just a second. All right, so now
hear something beautiful?
Is 12 take away 10?
Yeah.
Tell me what that is.
It's going to be really loud. You might want to turn your volume down.
What's 12 take away 10, guys? Those of you who are with me. 12 take away 10. What do you get? 2. I hear you. Okay. So now, is it a positive 2 or is it a negative 2?
Positive.
Positive. You still remember things. That's good.
What's a positive? Guys, how did that talk about the other
so now let's combine all of this and rewrite all of this into the form of A plus BI.
And then
All right, we want to rewrite this into the form of A plus BI. Okay, so what is 8 plus 15? 8 plus 15. We get 23. So 8 plus 15, this right here is 23. And then the imaginary part that we're left with is 2i. So what is the answer to 2 complex numbers multiplied together? Well, it's another complex number, all right? 2 times 4 is 8, but 2 with all this imaginary stuff and 4 with all this imaginary stuff added together is actually 23 with all this. So look, if you need to pause for a second to kind of get your brain wrapped around what just happened, please ask me any questions. If there's any part of this that's confusing you, please let me know, because what's really important is you understand the FOIL method, not that you understand all this mess right here, okay? All right, so you need to grasp this setup, these little arches that I've drawn here. You have to understand that, okay? So let's go over here and do it again. Let's do FOIL method, but let's try and write as little as possible in our answer, okay? So we should all know what 2 times 2 is, all right? We get 4, right? And then we got the outer terms, which is 2 times negative. Now remember, it's sticky, negative I, okay? So 2 times negative I, okay? And then the inner terms are going to be I times 2.
Hydrate or dihydrate.
Okay? And then the last term is going to be I times what? I times negative I. Okay? So if you want to know where these are all coming from, this is first, outer, inner, last. I'm just trying to save you from seeing all this crud and try to realize what's actually happening here. Okay? All right, so now let's look at this. I times negative I. That's going to be negative I squared. All right, but I squared itself is negative 1 according to our chart. So if you take negative I squared, the I squared part itself is going to be negative 1, but there's a negative out in front. So what this is going to be is positive 1. Okay. So we already know the real part of our answer is going to be 4 plus 1 or 5. Okay. So we're trying to get A plus BI. Now, what's the BI going to be? It's going to be the imaginary part, and that's going to come from right here in the middle where the outer and the inner terms were multiplied together.
All right, mate. Can you just
and we get, on this one we get negative 2I. On this one we get positive 2I. And I'm going to ask the class a question, those of you who are listening. What is 2 take away 2?
0.
Oh, I'm listening.
You got it. I hear you. All right, you got 0. Okay, 0 what? 0 what? 0 what? I. That's right. So in other words, there is no imaginary part to this problem. It doesn't exist. There is nothing but real going on here. So look at this. So really, you've got 2 complex numbers with an imaginary part. You see that? When you multiply, this proves, now look, I'm going to throw in the pencil down for a second. All right, you need to hear this. This is what proves imaginary numbers are real, okay, or actually exist. When you can multiply 2 numbers that have an imaginary part to get a real, tangible number. All right, so this, no kidding, is the number 5. All right, that proves it. All right, he's rickrolling me. All right. All right, so let's see. We've got okay, so we've got now we've got a much easier situation going on here. So we've got, instead of doing the FOIL method, we've got an imaginary number, I, times a complex number. And so all you're doing is basically distributive property here, and we get 3I plus 2 times I times I. Okay, so it's 3 times I plus 2I times I. So we distributed that I across for both of those. Okay, so we've got 3I plus 2I squared. And what is I squared? Can y'all all tell me now
Negative
what I
I
squared is? Can you remember?
It's negative I, right?
No, let's go back to your chart.
0.
You need to memorize this. Okay, remember it's over and over again. Where do you see I squared on here? Do you see I squared?
I'd like to point out that I was not here.
Oh, you weren't here Monday. So if you'll let me go back over this. So I to the 1 power. We were talking about last Monday. Square root of -1, and that's what that is. An imaginary number is actually the square root of a negative number, -1. Okay. So in order to take something like this that does not exist in the real world and make it real world, you can multiply it by itself and make it real. You see that? Okay. And some people, even back in the old days, like in the old Roman times, they did not use negative numbers. Those did not exist. Okay, they only used in the early first century. They used only natural numbers. You know, the numbers you count on your fingers. I mean, that makes sense, right? So I've got 1 coin, 2 coins, 3 coins. I can count that, but I can't count negative coins, right? So they knew they were there, but they didn't have the proof that they existed. It's kind of like the way that we have imaginary numbers now. We know they're there, but you can't really prove that they're existing unless you work out the mathematics. And luckily, these days, we have such technological advancement that, I mean, we've got, I would guess probably in the 30s or 40s that they had proved that this had happened. I mean, it's been around for a while, okay? So, but if you take I and multiply it by itself 4 times, you get 1. If you take I and multiply it by itself twice, you get -1. All right, so let's go back over here and let's look at this section right here. We were talking about what is I squared? Well, it's -1. A real tangible number. Okay, there's still going to be an imaginary part here. That's okay. I want to rewrite this accurately. I want to rewrite this in the A plus BI format.
Wait, -1 time. Oh wait, never mind. I'm stupid.
So what's it going to be? Is 2 times -1 is going to be what? -2. You see that? So 2 times -1 is -2. This is the real part where A is. And then you have this imaginary part, which is 3i. So what's the answer to this? It's this, okay? When you multiply these two imaginary or complex numbers together, you get this imaginary number. And that's what that all comes down to. And it's not about you understanding this material. It's about you understanding distributive property, about you understanding FOIL method. That's what you need to grasp, okay? All right. So, and it basically, you guys have done this in 7th grade. That's why this is getting so complicated now. You're getting all the algebra stuff, all the letters thrown into your, okay. So I was just, anyway, so let's go over this real quick. Let's go back to, what we were doing. Can anybody explain to me what now that you've seen the last 2 problems? Okay, what do you think I need to do first?
Okay.
Can those of you who are with me, what do you think I need to do?
I love how every time I play a sound, he says that. I'm paying attention. I'm just doing my own thing while
I know you're always paying attention. Those of you who seemingly don't pay attention, I promise you, I know those who have A's, okay, in the class.
Do I have an A? You never put in those 3 100s for me.
Oh, you're talking about, yeah, we'll get into that later. I'll go back and type those in. I remember what you're talking about. But do you really need them? I don't think
Yes, I have
no,
B.
you don't. I mean, you're going
I have a B. Yes, I do need them.
You know what? You know what I'm going to do? I'm going to give them to the redheaded guy that's with us.
Yay.
I'm going to give them to me because I did the work.
You did the work, but the redhead gets it. Oh yeah, there you go, Mr. Penn. Mr. Penn Tapper. All right. Okay. So let's go back. What you were supposed to say. Hey, what you were supposed to say is I need those 300. You were supposed to say FOIL method. Can we all say it together?
Yes, I need the FOIL
Hey,
method.
Let's all say it together. 1, 2.
I need the FOIL
method.
Yeah, see? Okay, so we got first, outer, inner, last.
Talk about I ate a burrito and then I had to
So
I went to the bathroom and there was an employee in the stall, so I pooped my
okay,
pants.
so what we get here, can anybody tell me what the first 2 numbers that would be multiplied would be?
Non-banned from Taco Bell.
Okay, one of my students is taking care of her chickens. That's cool. You keep doing it.
I'm talking about I threw my underwear at a Taco Bell
You need to
employee.
make sure and start selling those eggs too. Be an entrepreneur. Hey, I'm all about
and then the
teaching my
employee
students how to
started
become
to lick it
successful
off and
adults.
was like,
And if it takes selling eggs to become a successful adult, you go right on ahead and do that.
And then I was like,
Because,
what
listen,
the
there's people that
heck?
need D-Days.
Why is this
People like
talking
Mr.
about
I need 300s.
my food?
All right. So what 4 times 2 is 8. And then okay, 4 times -6 is -24i. So what I'm doing is I'm assuming that you guys know what I'm talking about.
Yes.
Okay,
Yes.
so 3i times 2. I can't look at you in the eye like I did in the classroom and know that you're hearing me. So I'm going to have to use my telepathy here.
Yes.
Okay, so we've got -18i squared. Okay, now stop everything you're doing. All right, everybody freeze. Okay. Now we're going to circle this I squared. You're supposed to know what I squared is.
Guys, I'm a girl now.
Do you know what I squared is? I squared, you're supposed to say -1. Okay? We just got through with that up here. All right. So now look, guys, I'm going to go ahead and I'm going to finish today. This is going to be the last question I do today. I'm not going to get to 5-2 like I wanted to. I'm probably going to do a Zoom tomorrow. And if you want to be a part of that, that's fine. If you don't want to be a part of that, that's fine. But I'm going to go ahead and do, since I missed yesterday, I had a family member pass away, and I had to go take care of that situation. I'll make up for it by being here tomorrow at the same time and go over 5-2. So when you get here tomorrow, have 5-2 ready. We're going to go straight into this, okay? It's called complex numbers division. And if you'll go and print off pages 10 through 15, if y'all have printers, hey, if you don't have printers, go to the library if it's open. I hope the library is open. I don't even know if it is.
Oh, we should be socially distancing and not going to libraries.
Okay, so this is the last problem that we're going to do. And we're going to get, what is this, 8. We're going to add together the 2 real parts.
Social distancing be like
8 plus 18 is 26. All right. And what is the imaginary part? That's going to be -24 plus 6, which is going to be
-18.
Negative what? What's
I don't know
-24 plus 6? Can y'all tell me?
This is a really weird voice
Last
effect.
question before we end it today.
-18.
-18. I hear you. I hear you, Mr. Super. I hear you. Okay, so we've got 26 and -18. Okay. So we're going to add this together, and look, it's already in the A plus BI format, right? The standard form of a complex number, where you have a real part and an imaginary part. All right, so we've taken 2 complex numbers, multiplied them together using the quadratic FOIL method. And it's kind of like a souped up distributive property. And then we get an answer of 26 plus -8i. I'm going to end it with a goodbye. Guys, I hope to see y'all again soon. I know I will see you hopefully around town somewhere. But
no, you won't. We need to be socially distancing and not
Mr.
going
Robot
places.
says no, I won't. Okay. Fine, I won't see
We
you.
need to not go anywhere at all for the 2-week social
But,
distancing period. Otherwise, we're going to get
I'm sorry, I
corona.
didn't mean to say your name. Take care of those chickens. Mr. I need 3 100s. I'm going to see what I can do about that.
Actually,
I need
only
3
2.
Super, go ahead and be the trooper I told you to be. Mr. Redhead, I'll give you all of you know who's hundreds, okay?
It's actually only 2 100s, and I did the programming work for them, so give them to me.
I'm going to give Mr. Redhead your 3 100s.
Then you're going to give me 6 of them.
Because he got here before
I
you
need
did.
10 100s.
I couldn't get my internet to work.
Okay. All right. So that
I say as I
would be
play
pretty
video
interesting.
games.
That's what makes this class interesting is the
The
robot
fact
voice.
that I can do this.
That's what makes the life worth living. Okay. So tomorrow we'll get back to normal. I'll even show you Charlie, and we'll see what happens. All right. Bye, guys. I'll see you. I hope you have a good week. Miss you guys. I really do. All right. Bye.